Welcome to the Digital Forensics series on memory forensics and volatile data analysis. Modern attackers often operate entirely in memory, avoiding disk write. This video covers essential skills for blue team and incident response, including RAM analysis, process injection, credential dumping, and rootkit detection. Volatile data is information stored temporarily in system memory that disappears when the system shuts down or reboots. This constant change makes memory analysis extremely time-sensitive. Advanced attacks often leave minimal disk evidence but significant traces in RAM, making volatile data capture a priority. RAM analysis helps investigators capture memory dumps and analyze them for evidence that may never exist on disk. This includes identifying malicious processes, suspicious connections, and recovering authentication artifacts, as well as uncovering injected code and hidden shellcode. Process injection is dangerous because attackers insert malicious code into legitimate processes, hiding inside trusted applications. This technique evades file-based antivirus, maintains persistence, and the injected code exists only in memory, making memory forensics the primary detection method. Credential dumping steals authentication data from memory during active sessions. Attackers target oxygen monosulfide stored credentials to escalate privileges. Key targets include password hashes, Kerberos tickets for pass-the-ticket attacks, LSASS memory, and session tokens that allow authentication without passwords. Modern malware increasingly operates entirely in memory, leaving no traditional files on disk. This fileless approach evades antivirus tools. Memory analysis helps investigators identify suspicious memory regions, malicious code execution, and hidden payloads, which is critical in modern malware investigations. Rootkits are designed to hide attacker presence by operating deep in kernel memory, drivers, and system structures. Normal monitoring tools often cannot detect them. Detection involves identifying hidden processes, hooked system functions, kernel modifications, and concealed network connections. Modern attackers prioritize stealth and evasion, relying on in-memory execution and legitimate system tools. This renders file-based security insufficient. Detecting these threats requires in-memory execution analysis, leveraging legitimate tools visibility, behavioral analytics for anomalies, EDR telemetry, and proactive threat hunting. Memory forensics is vital for incident response, live triage, and evidence capture during active breaches. It allows for malware analysis by extracting payloads without execution and supports threat hunting for indicators of compromise. It's also key in ransomware investigations and detecting nation-state activity. The key takeaways are that system memory holds valuable evidence. Mastering memory forensics enables blue team professionals to detect stealthy attacker behavior that file-based tools miss. This includes RAM analysis, detecting process injection and credential dumping, finding fileless malware, and uncovering rootkit manipulation. Up next is threat intelligence operations.